Hi students, welcome to the session on plane wave propagation in lossy dielectrics. Right. So in this chapter we are going to study about the plane wave propagation in lossy dielectric, lossless dielectric, free space, and good conductors. But plane wave propagation in lossy dielectric is a general case. Right. From this we can derive the equation for plane wave propagation in lossless, free space, and good conductors. So it is better to learn this first, then apply the conditions for this medium, and we can derive the equation. So let us start with the plane wave propagation in lossy dielectric. Right, as a name itself is telling the what is lossy dielectric. The lossy dielectric is one. It is not pure dielectric. What is dielectric? It is insulator. Lossy dielectric means it is partially conducting. It is not ideally insulator. It is partially conducting. Dielectric is insulator. Lossy dielectric partially conducting. That means here sigma is not 0. Because ideal dielectric conductivity is 0. Sigma is conductivity. It is lossy, so sigma is not 0. Right? So what happens when plane wave propagates through this dielectric? When it is propagating through dielectric, wave loses its power. Let us see how it is happening, right? So when plane wave propagates through lossy dielectric, if it loses its power, the material which possesses this character is known as lossy dielectric, right? That is very, very important point. Now we go and derive the equation for plane wave propagation in lossy dielectric and learn the important points from that. So here we consider isolinear, isotropic, right? Homogeneous medium, dielectric medium. So the dielectric medium is linear, isotropic, and homogeneous with charge density is 0. So what is linear, isotropic, homogeneous? Please refer my video on free space. Okay. Now we will start with Maxwell's equations in polar form. So we know that Maxwell's equation in polar form is like this. Since rho v is 0, del dot E becomes 0 because del dot E, Gauss law for electric field is rho v by epsilon. Since rho v is 0, del dot E is 0. Other things we know how to derive, right? So this is what Maxwell's equations in polar phasor form. If you have any doubt, please my video on Maxwell's equation in phasor form, right? So this is what this one. You see, you take this equation, let us assume it is 1, 2, 3, 4. You see 3 and 4 are a coupled equation. That means electric field and magnetic fields are coupled. In the same equation, we have two different fields. What I want is I want individual field, right? So I want to know what is the nature of electric field and what is the nature of electric field, magnetic field when wave propagates in a dielectric. So I want to decouple. So in order to decouple, I take curl of equation number 3, both sides. So 3 implies del cross E. I take curl on both sides. Minus j omega mu del cross H. I know what is del cross E identity. So it is nothing but del into del dot E minus del squared E is equal to minus j omega mu. Del cross H is given here. You see del cross H is equal to sigma plus j omega epsilon E. Fine. So del dot E is 0 as per equation number 1. So this is cancelled. This implies del squared E is equal to j omega mu sigma plus j omega epsilon E. Fine. So this is one important point. Now we bring this left hand side del squared E minus j omega mu sigma plus j omega epsilon E is equal to 0. Del squared epsilon E minus gamma squared E, this one. I write this equation in this form. Fine. So here I write where gamma squared is given by j omega mu sigma plus j omega epsilon. right? So that's what I take as a gamma square. This is equation number 5, this is equation number 6, right? So these two equations are very, very important. Now you see this equation as purely E only. There is no H. Right, in the same way I do it for, see, from this one I got pure E. Similarly, you do the same thing for take curl on both side, and when you take del cross E, substitute this value here, you will get what you call as the equation del squared H is equal to minus gamma squared H is 0. Fine, so this is the equation we will get. No need to derive, it's a symmetry relation, so just you can say that follow the same procedure, we can get the answer like this. So this is equation number 7. Fine, so this is what now you see this is purely H, no E. Now these two equations decouples E and H from each other, right? So okay, fine. So what happens, this is purely E based equation, this is purely H based equation, right? So these two equations, equation number 5 and 7 are known as Helmholtz equations. So Helmholtz equations, right? So that is very important. Now you take about gamma and see what is the thing, what is the meaning and all, right? So gamma squared is j omega mu sigma plus j omega epsilon. This is what we are going to work, where gamma is known as propagation constant. We call gamma as propagation constant. Okay, so more we see this. You see, gamma is a complex number, real part and it has imaginary part. Since gamma is a complex number, any gamma I can write as a sum of real and imaginary part. Alpha is a real part, beta is a imaginary part. Fine. Okay, now what we do is, let us take gamma square, right? So square it, what is gamma square? Gamma square is equal to alpha square minus beta square plus 2j beta. This I square it. So already I know what is gamma square. This is gamma square. I equate that. So j omega mu sigma plus j omega epsilon. I multiply this sigma jj minus 1. So minus omega square mu epsilon plus j omega mu sigma. Fine. Now you equate real part on both side. Equate real part. This is what my real part here. So okay, that is minus alpha squared minus beta squared. Right hand side, this is my real part. So minus omega squared mu epsilon. So this will be equal to beta squared minus alpha squared is equal to omega squared mu epsilon. Okay. Similarly, we square, find the magnitude of gamma squared. So what is mod gamma? Mod gamma squared. Gamma is alpha plus j beta. What is mod gamma? Alpha squared plus beta squared. Because gamma is equal to alpha plus j beta, mod gamma is alpha squared plus beta squared. Mod gamma whole squared is this one, that is given by alpha squared plus beta squared. Clear? So that's what we have to know. So I bring here. Fine. So you see alpha squared plus beta squared. Alpha squared plus beta squared is equal to gamma squared. So I know what is gamma. This is my gamma square, right? So I want magnitude of gamma square, right? So what is magnitude of gamma square? I have to take this magnitude because gamma squared is equal to this one. So this implies what is mod gamma squared or gamma squared is equal to, take the modulus. It will be, what is the magnitude of this one? It is given by omega mu. Magnitude of this one is sigma square plus omega squared epsilon squared. So I can write mod gamma squared like this. So already I derived one mod gamma squared. What is that mod gamma squared? Alpha squared plus beta squared. So that is equal to this one, because this is also mod gamma squared. So alpha squared plus beta squared is equal to mu omega sigma square plus omega squared epsilon squared, because this is mod gamma square, this is also mod gamma square. So I equate both. So when I equate this one I got. So alpha square plus beta square. Fine. So what is the equation number I can put? I already have 7 equations. So let us take this is equation number 8. This is equation number 9. Fine. So if you add 8 and 9, what you get? So if you add 8 and 9, so you will get 2 beta square is equal to omega squared mu epsilon plus omega mu into sigma squared plus omega squared epsilon square, right? So simplify it, that is equal to beta squared. Fine. So omega squared, omega, what I do, 2 beta squared is equal to omega squared mu epsilon plus, I take omega epsilon outside, omega squared epsilon squared, so it will be omega squared mu epsilon. I take omega squared epsilon squared outside, so it will be 1 plus sigma squared divided by omega squared epsilon square root. This I take outside, so omega squared, I write it, omega squared epsilon squared into 1 plus sigma squared omega squared epsilon square. This omega squared epsilon squared, I take it outside, so it will be omega squared into mu epsilon. Fine. That is divided by 1 by 2. So what will happen? So if you take beta square, you take omega square outside, so omega, right, into mu epsilon common, so mu epsilon divided by 2. Fine. Otherwise fully, let us deal it. Mu epsilon, I take it outside, so mu epsilon I take it outside means omega, also omega squared I take it outside, omega squared by 2 mu epsilon, this is 1 plus sigma squared by omega squared epsilon squared, this is plus 1, right? So this is what this implies beta is equal to omega squared, omega I take outside, root of 1 by 2 mu epsilon, so mu epsilon by 2 into root of 1 plus sigma squared by omega squared epsilon squared plus 1. Fine, this is what beta value, right? So similarly, subtract 8 and 9, 8 from 9. So what you get is you will get alpha. Alpha is equal to omega into mu epsilon by 2 into 1 plus sigma squared by omega squared epsilon square minus 1. This is what alpha value, right? You don't need to derive, just to say that. Okay, so anyway it will be being like that only. So 8 minus 9, equation subtract 9 from 8, you will get the alpha value, right? So this is what beta and alpha, right? So next we have to do some important interpretation of this equation. You see, in this equation, if alpha 0, what happens? If alpha 0, this will be 0, alpha 0, sorry, sigma 0 means it will be 0, so root 1 minus 1, it is 0, 0, so totally it will become 0. That means what? Alpha is equal to 0. When sigma 0, sigma is 0 for lossless dielectric, right? So for loss, I am talking about lossy, just we talk about, for example, if lossless, in lossless medium or in lossless dielectric, what happens? The alpha is called attenuation. Attenuation is 0. That means what? Attenuation means a reduction in amplitude. So when your wave propagates through lossless medium, what happens? It will propagate without any attenuation. So attenuation 0 in lossless medium. That's what it is called, lossless medium. Whereas in lossy dielectric, I told when wave is propagated, it gets reduced its power, right? So that's what this one. So here for lossy medium, alpha is not equal to 0. This is not 0. This implies plane wave propagation in lossy dielectric. As the name itself is telling, lossy dielectric got reduction in power while it is traveling through a dielectric. That's what this one, right? So that is the important point. So that's what alpha. Beta is nothing but right? It's a measure of phase shift per unit length. Phase shift per unit length. Okay, so that is very important point to be discussed. What is the thing is, you see a wave is propagating like this. Let's take a sinusoidal wave because we are dealing with phasor. So this is what we know, lambda, wavelength, length of one wave, lambda. So here how much angular displacement it has undergone? 2 pi. So what is beta? Beta is phase shift per unit length. So for lambda, the phase shift is 2 pi. For lambda length, the phase shift is 2 pi. For unit length, it is 2 pi by lambda. So that's what beta is equal to 2 pi by lambda. Fine. So that we have to remember. And velocity in terms of beta is given by V is equal to omega by beta, right? So this is what another thing we have to know. What is beta? Beta is phase constant, right? Which is nothing but phase shift per unit length. Alpha is attenuation, right? So that is the another point we have to note. Okay, so now we study about alpha, beta, gamma. Gamma is a propagation constant, right? So we found values of alpha plus j beta, that is equal to gamma. For alpha, what is the alpha value in lossy dielectric? This is alpha value, this is beta value. These two equations are very important equation. We have to use it in the problem. So 8, 9. Okay, this is I call this equation as 10. This equation is 11. Fine. Okay, now we see what will happen when wave propagates. Okay, so okay, let us assume that wave propagates in z direction. Wave propagates in az direction plus az, right? So and it has only x component, right? Assume wave propagates in z direction and it has only electric field as x component only. Similarly, we will derive a magnetic field equation. So first we derive electric field equation. So how can we write electric field? So this implies E vector is equal to Ex. It is having only z component and Ax. Fine. So that's what we know. So this is what fine. So this is what my E, right? So E propagates along right, okay, E propagates along x direction, right? So and it has one wave propagates in x direction. Electric field is having only x component, right? So please remember, so wave in z direction, electric field is propagating along x direction because it has only x component, right? Any vector can be written in terms of its magnitude and its unit vector. So unit vector is Ax, right? So this is what Ax. Similarly, so we know that del squared, right? Already we know del squared E, Helmholtz equation, minus gamma squared E is equal to 0. So this implies del squared minus gamma squared E is equal to 0. Substitute this equation here. So what happened? Del squared minus gamma squared E vector is equal to 0. Fine, what happens? Del squared, you see del squared is dou squared. E is nothing but Ex z. Okay, I write again. Okay, E is E vector. Fine. E x z ax is equal to 0. This means dou squared Ex by dou x squared plus dou squared Ey by dou x squared plus dou squared Ez by dou z square. So here also x, x, right, minus gamma squared Ex z is equal to 0. We know that electric field varies only in x, Ex, Eyz, Ez, right? So we know already electric field varies in x direction, right? So there is no change in y and wave propagates in z direction, and you see this is Ex is a function of z. So when you're differentiating something with a function of z with respect to x, the result will be 0. Here this is a function of z but differentiating with respect to x, so this is Ex only. It is a function of z but differentiating with respect to x, the result will be y dy square. The result will be 0. Here it is a function of z and differentiating with respect to z, it is not equal to 0. So what happens? I have dou squared Exz divided by dou z square minus gamma squared Exz is equal to 0. This implies it will become d square because it is totally only one equation is there. There is no need to go for partial differential equation. So I can write d square minus dz square minus gamma square Exz is equal to 0. Now you see it is a scalar wave equation. It is a scalar. It's a scalar wave equation. It is a second order equation. So for this, the solution will be in the form of Exz is equal to EO e power minus gamma z plus EO dash e power plus gamma z. It's a general solution for a second order differential equation. Fine. So, but here you see we assume the wave propagates in z direction. That means z direction, right? So, which is talking about z direction here? E power minus z is z direction. The wave propagates in positive z direction. Here it indicates the wave propagates in negative z direction. So what is the electric field? E0 dash is the magnitude of electric field at that point. So since our wave is propagating in plus z, that we cannot have a electric field in minus Ez. So what will happen? This will become 0. E dot dash is equal to 0 because wave doesn't propagate in minus z direction. My wave is propagating in plus z direction, that is given by e power minus gamma z. E power plus gamma z is talking about wave propagation in minus z. What is the electric field? At the time there is no electric field, so E dot dash equal to 0. So what will happen? My Exz will be equal to, so Exz is equal to E naught into e power minus gamma z. Okay, so that is the point we have to remember. Now what we have to do, we insert the factor e power j omega t in order to bring the phasor form into account. So multiply e power j omega t with this. I can take sinusoidal format. So what will happen? Now I bring t, so the equation becomes E z of t. That is equal to, I want this one real part, so I can write Ex, right, z, right, e power j omega t. This is what my E z of t, z comma t. So that is equal to real part of Ex of z e power j omega t. That means I multiply this. Fine, left hand side and right hand side. That's what E z of t. So what will happen? Ex Ez of t is equal to, so now bring a vector direction where it is propagating, electric field is propagating next direction, so make it. So E vector is equal to this one, sorry, its magnitude. Fine. So what will happen? So this will be, this direction is E, Ax direction. So this will be equal to, this is Ax, right? I can write what is the real part of e power j omega t. Ex is equal to real part of E naught e power gamma. Gamma is alpha plus j beta z into e power j omega t into Ax vector, right? So this will be equal to real part of E naught e power minus alpha z e power omega t minus beta z into Ax vector. So what is my E z of t? E z of t is given by its real part of E naught. E is nothing but this one, E naught e power minus alpha z. These are all real part. What is the real part of e power j? E power j omega t minus cos beta z. It is cos of omega t minus beta z Ax vector. These are all real part. Directly I write e power j real part is cos omega t. So this is what electric field in electric field of wave propagation in Lossy dielectric, electric field equation, right? So this is very important equation, right? So E we got like this. Similarly H we have to find. How can we find H? H we can find with simplicity. H of z comma t is given by, follow the same procedure, no need to derive. It is a symmetry relation, so we can write H naught e power minus alpha z e power j omega t minus beta z, where it will propagate, magnetic field will be in AY direction. That is the only change, right? Wherever you find EH, so what will happen? This will be giving, right? So I have to know what is my H naught. H naught is given by E naught by eta, right? So we will derive these things later, but just you remember H naught is equal to E naught by eta. So that will be where eta is equal to, it's a complex number, mod eta into e power j theta. Now you substitute h naught value here. So what will happen? It is real part of, instead of h naught you substitute e naught. Instead of eta you substitute eta mod into e power j theta e power minus alpha z e power j omega t minus beta z ay vector. So it will be equal to real part of this one. So real part means these are all real part, e naught e power minus alpha z. This e power j theta, here it will go e power minus j theta. So real part is cos omega t minus beta z minus theta. Fine, that is what hz of t, right? So this is very important. Let us consider this is a final equation for magnetic field B. So equation is B. So what is, you see, real part is electric field is AX direction, wave propagation we assumed in Z direction. So it is E is equal to E naught e power minus alpha z cos omega t minus beta z. Here E naught e power minus alpha z cos omega t minus beta z minus theta. So I write my electric field equation for simple understanding. Hs of E z of t is given by, simply I can write E naught e power minus alpha z cos omega t minus beta z into Ax vector. So electric field is along x direction, magnetic field is along y direction, wave in z direction. So electric field is perpendicular to magnetic field, that is perpendicular to wave propagation. All three are mutually perpendicular, proved. Next thing we have to remember is, you see, when wave propagates through the lossy dielectric, you see its amplitude that is reduced by the attenuation factor. So that's what wave, what happens, the wave gets attenuated. The wave gets attenuated while propagating through lossy dielectric, because the amplitude, maximum amplitude is reduced by the factor of e power minus alpha z, right? So that is what we call as attenuation constant. Alpha is attenuation constant, right? So this is important parameter, right? So alpha is attenuation constant, amplitude is reduced by the factor of e power minus alpha z, right? So simply it is a measure. What is attenuation? So it is a measure of the spatial rate of decay of the wave in the medium. Fine. So that's what attenuation, right? So I hope you understand this clearly. Attenuation is given by the unit Nepper per meter, NP, right? Whereas beta is a phase constant, that is given by 2 pi by lambda. It is nothing but radian. Lambda is a length meter, radian per meter, right? So that's all about this session. If you have any doubt, please ask me in comment section. Thank you.